Welcome to springlib.
We're told the two curves are orthogonal if their tangent lines are perpendicular at each point of intersection. We're asked to show that the given families of curves are orthogonal trajectories of each other. That is, that every curve in one family is orthogonal to every curve in the other family. Then we're going to sketch both families of curves in the same axes. Well, our families of curves are y equals ax cubed. So these are translations or transformations of the cubic function where it's stretched vertically, and the other family of curves is x squared plus 3y squared equals b. So these are ellipses centered at the origin, which appear to have a horizontal major axis. Well, there's three steps here. First, we want to differentiate the equation of the family of curves so that the constant in the first equation gets eliminated. Then we'll obtain a differential equation. And finally, we'll solve the differential equation we obtain. So we begin with our family of curves y equals ax cubed. Now I'll solve for our constant so that we get it on one side. I get y over x cubed equals a. We want to find the derivative, the slope of these curves, but we want to find it independent of the constant a. So, taking the derivative with respect to x at both sides, we have the bottom x cubed times dy dx minus the top y times the derivative of the bottom 3x squared, all over the bottom x cubed squared, which is x to the sixth, and the right-hand side is simply 0. So now I've eliminated a. This is good because now our slope is only going to depend on y and x. Solving for dy dx, we have x cubed dy dx minus 3x squared y equals 0, and therefore dy dx equals 3y over x. Now, this is the slope of our first family of curves. We know that the slope of our second family of curves, well, this has to be the negative reciprocal. So this is going to be, we want to substitute negative dx dy for dy dx. So the tangent lines are perpendicular at the points of intersection. Therefore, we get negative dx dy equals 3y over x. This is a separable differential equation. We can write this as x dx equals negative 3y dy. Now I'll take the antiderivative of both sides. So we get 1/2 x squared equals negative 3/2 y squared plus a constant, which I'll call c. I get x squared plus 3y squared is equal to 2c. If I set 2c equal to the constant b, then the equation becomes x squared plus 3y squared equals b. We recognize these are the same as the family of equations we were given. Therefore, it follows that the given families of curves are orthogonal trajectories of each other. So we have verified this fact. Now I'm going to sketch both families of curves on the same axes. As I said before, the first family of curves, these are transformations of the cubic with, I guess you could say, the vertex of the cubic at the origin, and they're just stretched vertically or horizontally. So for example, if A was 1, we'd have something like this. And we get steeper. Of course, we can also get flatter. We can also, if we have a negative A, flip it so that we're like this.
Anyway, we did microanalysis studio like I have defense for being I've been laboriously podcasting. You've been in the podcasting mines. Yeah. And I'm recently a new vegan, so my body hasn't adjusted yet. I really have not much. Yeah, that's right. You know what? And that's why right now publicly.
Now the second family of curves, as I said, these are ellipses with a horizontal major axis centered at the origin. So they probably look something a bit like this.
Yeah, I'm so sorry. Each and every one of you beautiful fucking people out there. Yeah. Will you suck their dicks? That I routinely let down. Will you go home? We had a couple of bits on this one, you know. Make fun of the impressions. Well, we started with gay Star Wars. That was fun. Yeah. Gay Star Wars was great. The first 25 minutes were great. I know a lot of you are going to say this episode is bullshit. How many times? Little eating on mic, dude. Just you want to say is the 3-week one. I was playing video games the first half and it was great. I was not paying attention to the podcast. Yeah, but that's more passive. I was able to come in.
Looking at the ellipses and the cubic functions, they do appear to be orthogonal trajectories of each other. That is, the tangent lines at the points of intersection, like here, 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 and here, do appear to be orthogonal.